Today's first speaker is Jonathan Doherty. Jonathan is the Business Development Manager for Heidenhain Corporation. You may have seen their booth out front. Heidenhain is a German-based manufacturing company at the forefront of semiconductor, electronics, metrology, automation, medical, energy, biotech, and a bunch of other global markets. The company has been supporting these industries for over 130 years, and they just finished working with the ABB Gopher robot. Jonathan failed to provide me with any fun facts about himself, so I Googled him. And I'm happy to share that he hasn't aged a day since he was hired in 2014, so he's probably a vampire. Let's give Jonathan a big hand.
Appreciate it, thanks. All right, thanks, appreciate it. All right, so today I'm going to be talking about robotic encoders from our company Heidenhain. So I appreciate the intro. You can see some of the solutions every time I turn my head, okay, that we have up here on the screen. And so I'm going to give a little bit of a background on what encoders are, and then also some of the new innovations that are helping to support the growth in the robotics industry and what they're looking to do going forward. So I do ask maybe no pictures, please. There is some confidential stuff in here, but if you do have any questions, please feel free to ask, and we can ask afterwards. So, key characteristics for robotics in general. When we look at the robotics market, there are some certain things that, in general, people are looking to improve upon as we go forward into the next age of robotics. And so, right off the bat, one of the big things is obviously performance, right? Everybody wants to be faster, wants to be more accurate, more repeatable. And what that comes with is, better integration of components and better sensing capability. I don't know if some of you may have heard the term like Industry 4.0 or Industrial Internet of Things. As we see more automation and more shift towards automated manufacturing, robotics have to be able to do tasks that were previously not capable of doing. And so that's where this higher performance drive primarily comes from. But with that, we go to our second topic there is robustness, right? You want these robots to work in multiple different environments. They have to be able to work around humans. They have to be able to work in manufacturing environments, different temperatures, going through a cycle in a manufacturing warehouse in the different times of the day, vibration, some sort of dust, contamination. They have to operate in all of these different environments. And so robustness of the robotics is definitely very key. And then helping to support all that are also the sensors. This is where our encoders also come in, and I'll get to that in a second. But you have other sensors too that are being integrated. Things to help with the dynamics, torque sensing, joint and axis tilting, temperature sensors to make sure that your components aren't overheating. All of those are going in and basically providing more and more information for the robot to be able to draw from. And then finally, the big thing is safety. So a big trend that we're seeing in the robotics industry is historically you would have these large industrial robots. You think of something in like a automotive manufacturing plant or a welding. You'd have these large robots operating in very restrictive spaces or in cages basically. So anytime anybody entered that space, the robot would have to shut down because you don't want to risk, injuring your workers. You want to be able to make sure that there's no possibility of a potential failure. As we move forward, we want robots to actually work collaboratively with humans, right? You want to be able to have a human worker directing and working with a robot as it does the task that it's involved with. So this is where things like cobots or collaborative robots come into play. But as you work with humans, you also need better safety. You need better redundancy to make sure that the robot isn't going to suddenly move or have any sort of reaction that could potentially harm the individual that it's working with, right? So we're moving towards dropping those cages, but ensuring the safety of those workers with the robots as well. And so these main four things drive a lot of the industry forward, but also drives for us as a component of robots how we develop as well. So within a traditional robot arm, what our company focuses on is basically the component inside of the robot. So we do a lot with internal motor feedback. So the motor that's driving those joints and the overall movement, we're providing that feedback on the speed with our encoders. We're also doing internal joint positioning. So as you have the movement, you want to know exactly where you are down to, arc second level, which is, basically 360th of a degree. So really small increments within those rotary positions. And then also the communication between those, right? So you have all these different sensors, you have all these different inputs coming from different levels of the robot, and you need to standardize and have a solution that brings that information back so that you don't have hundreds of different wires being routed through your robot overall. And so our company, Heidenhain, focuses on trying to improve each of these elements and provide the best solutions for the next age of robotics going forward. So as we talk about the first step here, internal joint positioning feedback, we can talk about some solutions that already exist and some new ones that are coming around too as well. So for joint positioning feedback, a lot of the common solutions that we see out there are magnetic encoders. And so these are very cost effective. They usually use partial arc scanning that you can see here. And you can do absolute positioning, which means that you know exactly where it is on startup, but it usually takes something like a calibration run or something like that. So our company saw that, okay, there's some room for improvement here. There are things that I think are really good, but there are also things that I think we can improve upon. And so we developed our inductive encoders on the right-hand side. We also have some examples at our booth if you want some hands-on feel of these. And these are basically a 360-degree scanning solution. So as opposed to just having a partial arc, where if something like eccentricity or some sort of tilt happens, you could potentially lose signal. With ours, 360 degrees around, able to compensate for that tilt and actually have really wide mounting tolerances to help with that development, to help with that integration. They're also insensitive to things like magnetic fields, which would affect a magnetic encoder, and absolute at startup. So right away, if you power cycle your robot or if it turns off, right when you start up, you know exactly where you are because every single positioning on this encoder has a very unique code. So even if the robot moves or something knocks into it, it still knows exactly the positioning that it's going to. So we've seen a really big trend towards the inclusion of these within more and more robot designs. We're seeing a lot of integration due to the ability to handle even things like contamination and the no calibration. And then we also see things related to functional safety. So we talked about that portion, right, with the safety control. With functional safety, you get basically a safety integrity level. You can go 1, 2, or 3. And what you need in order to reach those higher levels is to develop things like redundancy. So with our encoder, you actually can develop 2 independent positions that can compare to each other. And then that makes sure that if there's any slippage or anything that's going on, your encoder knows exactly where it's at and what's going on. And so you don't have any situation where it could potentially harm an individual. So with that solution, we were basically looking at, okay, what exists and how can we improve upon it? But our company likes to also try to do more innovative things to push the market forward as well. And so that's where we come up with a solution for a 2-in-1, taking the motor feedback and the joint positioning and putting it together. So I got a little video here. Let's see if it works. So this is what you would see as a typical joint within a robot. And what we've done is actually take the motor feedback on the backside of this encoder and then have the gearing on the back of the joint coming through and then having positioning on the other side of the output shaft. So what this provides is instead of having 2 independent encoders within a solution, you can combine it into one and reduce your overall cost, reduce your overall size, all while eliminating, backlash error, zeroing error, all these things that contribute to inaccuracies within a robot development. So as we talked about, you're trying to improve the performance. These solutions provide that all while providing an advantage on cost and sizing as well. So as kind of a cut up, you can see here kind of the design from a basic sort of standpoint. You have the motor over there driving the overall joint, and then you have the gearbox on the back side that then drives the output shaft, which is connected to the back end of the encoder. So there's a ton of advantages that come from this, both from the cost and the sizing standpoint. But one thing that we've actually just started getting into is actually the ability to take both of those measurements and actually do torque measurement from it as well. So a lot of robots have functionality like safe torque off or safe torque functionality for safety as well. And a lot of the time you have to integrate a separate torque sensor into the system in order to do that. What we found with our testing data is that you can see here a torque sensor would be the blue, and then our solution is on the green. And you can see that it's very, very, very accurate to a standard torque sensor to the point where we've actually had companies that now can eliminate another component with our solution by being able to use the 2-in-1 encoder solution in the comparison. And so this is, again, another advantage, another cost saver with using the solution to drive the industry forward. And then the last thing I'm going to talk about is interface. So this is the connective tissue that brings everything together. This is basically the language that all of these components use to talk to the main computer of the robot. And so for us, we have an interface called NDAT, which stands for encoder data. And we've had a lot of iterations of NDAT over the years, starting actually back in 1993, so basically as old as me, and then having generational iterations going beyond that as well. And so our latest version is actually NDAT 3. And the big advantage for NDAT 3 is actually providing more communication capability, more sensor integration, all while providing a reduction of overall wires and a reduction of overall cost with a single cable solution. So with the NDAT 3 features, we have universal across all of our encoder brands, various scanning, various sizes, measuring principles, and things like that. And then also integration of other sensors. You'll see out in the showroom out there, there's a lot of different companies doing things like force sensing, temperature sensing. We even have some like vibration sensing stuff. And all of that can actually be integrated within the NDAT stream so that instead of having multiple wires coming back, it can be just over one cable communication. It's extremely fast. You can go up to 25 megabits per second. Even going into very long cable lengths, and then also providing diagnostics so that you can understand, okay, what's actually going on in my system, how is it working, and what is the overall current health. And then the details about, the communication of how it works. You can actually program things down to the encoder so that you can have commissioning data. You can even read out automatic system installation information so that your end user can know exactly how the mounting should work and what sort of conditions it should be operating off of. So all of this stuff is basically, able to be written down to and then read out by the end user of the robot or the motor that it's going into. And then finally, we talked about with safety. We always want to have safety first, primarily in mind, and we try to make it as simple as possible to integrate high level of safety within our solution using the NDAT 3 interface. So, just as a conclusion, we talk about the 4 keys of robotics going forward with the performance, robustness, sensors, safety. And our company focuses specifically on trying to, provide products for each of those. So we want to have dual encoders to provide overall performance to robotics going forward. We have a robust scanning method that allows you to work in multiple different environments, multiple different temperatures. We have integration of more sensors so that you could see more into your robot and understand what it's doing. And then of course, safety. We want to make sure that we have the top level safety performance to make sure that, everything's operating as it should. So yeah, that is the conclusion of my presentation. If you guys have any questions, please let me know, but thank you for your time. Appreciate it. Great. Anything from the group? Go ahead.
Sorry. You're providing components within a larger robotic system. I'm wondering kind of how NDAT interfaces with other programming languages, or maybe is it doing all of the controls in that protocol, or just wondering how it integrates with other things.
So for us, we actually collaborate a lot with motion control companies and motor controller companies. So a lot of the big names you'll hear out there like Rockwell, B&R, Siemens, Colmorgan, and NDAT is typically integrated within their motion controller for that sensor level communication with the encoders. So we work really hard to make sure that, all of those different solutions will have that, and so that you're able to integrate it into whatever sort of end project that you have as well. Absolutely.
Thank you. This might be a high-level question, but
no problem.
In robotics, things are becoming more advanced and more feasible. So kind of like the way it happened with the AI recently, that now everyone is building on top of ChatGPT. Where do you see that turning point in robotics where it will just become more commonly used and where is this revolution? Where do you put that in the future?
Interesting. That's a very good question. You know, I would say that there is a difference between the common usage of industrial robots, the common usage of consumer robots. So I'd say industrial robots, they've been used for decades within the automotive industry, and you're seeing a more shift towards automation in a lot of industrial spaces. I think COVID actually drove a lot of that because obviously you can't have workers coming in. We need to make sure that people are staying safe during that time. And automation was partially a solution to help with that, right? You can automate a line and then have it still operating. So I'd say industrial robots, you're starting to see that happen now. More and more industries are saying, okay, is automation a solution? How can we integrate it, right? Consumer robots, I think, is another side of it, right? The integration of robots within, you know, society as a whole, as a delivery driver, as cleaning the windows on the outside, elder cares, that's something I heard today. I think that's going to take more time. And again, as you work with humans, you got to make sure that you have that level of safety and make sure you have that level of comfortability that people are okay interacting with that robot. But you're starting to see the beginnings of that. I think that's a longer timeline. But you're starting to see companies starting to come out with those ideas, and I think that's just going to be a comfortability of the people with those interactions as well. Yep. Any other questions? All right.
Thank you, Jonathan.
Thank you so much. I appreciate you guys' time.